Okay. So here's the no constraint problem. So, well, we know eventually we're going to have to figure out the probability of having all three mats in group D. Right now the problem is we have 17 students and we got to put 5 in group A, 5 in group B, 5 in group C, and 5 in group D. And just to be clear, in this case, I'm assuming that we can tell groups B, C, and D apart. So they're somehow different from each other. Maybe they're at a different desk or something like that. Okay. So what do you do here? How do you figure out how you could put 17 students into group A, group B, group C, and group D?
Well, maybe we could use like choosing numbers.
Okay.
So, say you started with group A, so you have 17 students and you have to pick.
Oh, we get some room to write up here.
17 students, you have to pick 5 of them to go in group A. So that's 17 choose 5. Now you only have 12 students left. You have to pick 4 of them to be in group B. So that's times 12 choose 4.
Okay.
8 students left, and you have to pick 4 of them. So it's times 8 choose 4. And then the last one is just 4 students, and then you have to choose 4 of them. So that would just not do anything. Just be times 1, basically.
Yeah, or what choosing number would we
It
need?
would be 4 choose 4.
4 choose 4. Yeah, that's right. Okay, good. Hey, good job. So if we want to divide the students up into these groups, there's going to be 17 choose 5. Oh, sorry for bouncing the camera there with my knee. 17 choose 5 times 12 choose 4 times 8 choose 4, and then times 1. So what do you think this number is going to be? This is going to be a big number.
Well, so I guess you could say it's 17. It's about 17 factorial over, because you have 17, 16, 17, 14, there's 13, and then all the way down to 1, and then you have over 4 times 3 times 2 times 1, and basically that's 24 cubed, not counting the times 5.
Oh, interesting.
So 17 factorial over 24 cubed.
Well, that's a fascinating estimate. Factorial 17 factorial divided by 24 cubed. That turns out to be a little bit too high. That's about 25 billion. But that's an interesting way to think about it. Maybe we'll figure out why that's wrong or give such a high estimate later. But the actual, I just typed it into Mathematica, it's 214,414,200. That's what this is.
Okay.
Alright, so we have 214 million ways to put the students into these groups. So do you think our friend Bob is ever going to see all the different possible groups?
No, he's not, because there's a lot of them.
Yeah. Okay, good. Let's figure out how to put the 4 mats in group D now.